So our setup back here, the main facts are they have a setup fee of $75. It costs them $6 to make a shirt, and they're selling them for $15. And so in the top here, I just listed that information. So there's nothing too special about this. I'm just reiterating what was in that problem. And anytime you attack a story problem, either on paper or if you're using spreadsheet as paper, you want to rewrite that information to kind of get a better grasp about it in your head. So important things there are how to get profit. And profit is always cost. So we have two kinds of cost minus revenue. So altogether, I was figuring right here that to calculate profit, it's 9 times the number of shirts that I sell, and I have to take off the $75 that it costs to get the screen printing started. So I just entered a formula here that says take 9 times the number of shirts to the left and then subtract 75. So this tells us in each row what's the profit for selling that many shirts. So you can see we're at a loss until we get up past 8 shirts. So after we sell 9 shirts, we start making a profit. Now we want to end up with a profit of what? At least 500. Yesterday we saw on the table that somewhere between 63 and 64 shirts, we finally get a profit of at least $500. Questions on that? Too bad? I'll give you guys some time to build that in just a minute on your own. Over here, I kind of redid the same idea. I have that same exact formula for total profit. Take 9 times the number of shirts. But whereas in columns A and B, I'm just kind of going 1 shirt, 2 shirt, 3 shirts. Here, I'm just thinking I can plug in any number I want, and it'll just spit out the profit. So if Colt comes to see me and says, man, I'm good at selling shirts, I can sell 700 shirts. All right, if we sell 700 shirts, then we're going to make $6,225. Man, you're the guy. So just kind of a play around thing there, which is one thing I like about spreadsheets. Whenever you make a formula that has a reference in it, then anytime you change the reference cell, and that's going to automatically update over here. And something's wrong. Why isn't that calculating right? Oh no, that's right. Yeah. Okay. So moving on, we're going to do a slightly different problem next. So I'm going to get a new spreadsheet open. And this one is going to be for the latte problem. So take a look at your worksheet on that last page. Let's get the information we need to get this started. Hey, Emily. All right, so next page. Here we go. So we're going to do this spreadsheet and on paper. Put up a little more. Why don't you blow up? So as Emily said the other day, I think it was, where is this latte store? That's a heck of a deal. So we start with a card and we load it with $50. And then every day we're going to go get a latte for $2.63. And so what we want to do is we want to just make a spreadsheet showing what happens to the balance on the card each day that we do this. And then ultimately we want to enter how many days can we spend money on lattes before we run out, and will that make it a month? So those are the questions we're going to try and answer. So we get a $50 card, we got a latte that's $2.63, and we're buying one every day. Every weekday. Oh, that's kind of a catch. So paying attention to the details. All right, so I'm just going to list some information at the top. Let's see. How about card art? I'm going to put the $50 there. And remember, we don't have to type the $sign. We can just tell the spreadsheet to format it as dollars for us. And then latte cost is 2.63 and format that as dollars. And then I'm just going to make a note. I keep forgetting this important fact. This is every weekday. So then down here, I'm going to make a table of day versus card, I guess. Card amount, and how about card balance? So I'm going to start off with a day 0 when we put the $50 on the card. And I'll set the spreadsheet up in 2 different ways. So there's going to be a day 1 and a day 2 and so on. How do I figure out what the next balance is going to be? What are they going to do to my card each time I go in? They're going to reduce it by 263, right? So all I have to do is say equals. They have to check my previous balance, so I need that cell, so click on that, and then subtract 263. Now, I know that 263 is already on the sheet, but I'm going to retype it here, and I'll show you a trick about that later. So just hit enter. So what I did, I wrote a formula, and what that formula does is it looks in the cell above and takes away 263. And we want that to happen every day, right? Yeah, so we should just be able to fill that down a ways. So I just grab that and I just drag it down a while and see where it goes. Eventually, I'm going to go into the negatives. So drag it down till you get into the negative values, and then you can just, delete those negative numbers. Yeah. That. All right. So first thing I did is I typed 0 there and I typed 50 here. So in the beginning, I have $50. And then on the first day, I want to take my previous balance, so equals, click on the cell above, and subtract 2.63. Once I do that, I hit enter, so the computer remembers my formula. Click back on the formula cell, and then fill it down until you see negative numbers. And you just got to fill it down a ways and yes. If you don't fill it far enough, go a little farther. Once you see negative numbers, delete them. We don't need those. Next, we need to go back and fill the numbers down so we can see where we're at. So just giving it a pattern of 2 or 3 numbers, you can then fill that down. So we can see how many weekdays elapsed. So I've got 19 weekdays that have gone by. How many weekdays are usually in a month? About 20-ish. Somewhere around there, right? 5 weekdays, 4 days a week. What's that? Something wrong?
Just do Control Z. Just on the 47.
Got some negative numbers. So I like to exclude negative numbers. So put somewhere. Now back to 0 and 1, and it goes to. So did everybody get 19 days on this? Anyone having trouble? Here. Good. So here I'm getting in 19 days, I'll have pretty much exhausted the card. So we're going to turn this into an equation next. And then we're going to double check the answers to the questions that were asked there. All right, so think of the equation y equals mx plus b. What's the m supposed to stand for? What's it mean in general? Slope. What's slope mean? Rise over run? There was a phrase I gave you guys, 3 words, that means the same thing as slope. Anybody recall what it is? So this is the most important thing about slope. So another phrase for slope is called rate of change. So it's a rate because we're doing a division. Anytime you do a division, it can be a rate. It's a change because the rise is a change, go up, and the run is a change, go left or right. Okay, so it's a rate of change. What's the rate of change in this problem? Okay, so 2.63 is the number. What's that? It's negative 2.63, and what does that mean? Negative 2.63 what? Dollars, and one more part? We said it earlier. Not every week, but every weekday, yeah. So I'm just going to make it simple, I'm just going to say it's dollars per day. So anytime you think about a problem and you think there's a change and it might be a slope, there's 2 things you got to come up with. You got to come up with a number, and then what does the numerator of that number mean? What does the denominator mean? So every 1 day, I put a 1 down, we lose $2.63. So that's the slope here. So that's the M in my formula. What's the B supposed to represent? Anybody recall that from the other day? Yeah, it's the y-intercept. Now that's good for algebra, but this isn't really algebra class. So it has a more physical meaning. You may remember what I said the physical meaning was? And it's like slope is a rate of change. That's its physical meaning. The y-intercept is where we start. It's the starting point. So I think the most important things to know about these kinds of equations is that slope is the idea of a rate of change. The fraction, 2 things are changing together. And the y-intercept, that's the starting point. That's where we start at. So what did we start at here? $50, yeah. So we can come up with an equation here, a new page. So I'm going to write y equals negative 2.63 times x plus 50. So then the question is, what the heck do x and y mean? Sometimes we use other letters. What do you think x means here? Days, yeah, and more specifically weekdays, right? I keep forgetting that. Makes me confused. So that's the number of weekdays. So anytime we write down an equation, we should always say, what does x mean? What does y mean? What does y mean? Think about the second column in our spreadsheet. Yes, the card balance. So y is the card balance. So here's your challenge. So the letter there. Can you incorporate? So we wrote a formula that said take the number above and subtract 2.63. Can you write a new formula that uses this equation instead in your spreadsheet? So give it a try. Feel free to fail at first, and then I'll go over how I would do it. Yep. You need help? Okay. So see if you can incorporate that. Pretty good. So hit that on $50. Oh, okay, so you're using the numbers above. So I mentioned earlier, don't use the numbers above. I'm sure how you do that. But here, all we have to do is stop that, do that. Just click on the first, click together, and then subtract the first. I'm sure how to do that. So I'm going to get mine going here. We can compare notes. So I'm just going to put it off here to the side. I'm going to make a new column for weekday, a new column for card balance. Okay. So I'm going to do 0, 1, 2. Roll that down. Give you guys another minute to try something for a formula there. And so I'm hoping I'll type a different formula here and I'll get the same numbers I already have. Just want to set it up a slightly different way. All right, ready to go over it together? So if you look, you can see my column B and my column E have the same set of card balance numbers, but I have a totally different formula in column E than I have in column B. So I'm going to delete those and do it again. So starting in 0, what I want to do is just pretty much enter the equation I wrote down here, where X just points to the weekday I need on my chart. So I have to take equals. The formula says start with a negative 2.63 times, where do I go to get the weekday? Yeah, just the cell to the left here. So I'm just going to click right next to me and then add the 50. So my formula was negative 2.63 times X plus 50. Each X value is located next to me in column D. I hit enter and I fill it down. And so you may ask, well, who cares? Because that gives you the same answer you already had doing it the other way. So two different ways to think about it. This way, the first way, the computer is just saying, hey, take your previous balance, subtract, which is kind of the way the bank thinks about it when I buy something. They just remove whatever I bought from my balance. So that gives me my daily balance. This way over here, and it depends. If I don't know the balance from the day before, I can't calculate the new balance, right? So if I delete that number right there, everything else falls apart. On the other hand, this one right here depends on the actual weekday. So I have to have 2 columns there. But the cool thing about that one is if I don't know the previous number, it doesn't matter because I'm using the weekday to the left. So it's just a different way to organize it. Neither one's better than the other. They just both have pros and cons. Questions? All right. So one last thing on this, and then I'm going to let you guys work with it. You have a question? Oh, you're going to have numbers over here. So you're going to 0, 1. So you're going to go down to 0, 1. No, you can go. Put that back. We'll do it. Just only the 0, 1. Okay. Anybody else have a question? All right. So, are we almost done answering questions here? Let's estimate if the coffee card will last to the end of the month. Well, we actually calculate it instead of estimating it. Write a formula for a linear model. Did we do that? Yeah, that was that y equals negative 2.63x plus 50. Very important. Anytime you use things like y and x, you have to state what y means and state what x means. So if you just wrote y equals and you didn't say, hey, y is the card balance and x is the number of weekdays, your formula is incomplete. And then we want to use the linear model to calculate. Did the spreadsheet use a linear model? Either way, it used a linear model. Didn't we change it by the same amount each day? Yeah, that's a linear model. So the spreadsheet did give us that answer. The author of this, I think, meant us to try to solve it using algebra. Okay, so we're going to do that next just for fun. We don't do a lot of algebra in this class, but we do a little. So let's do a little right now. What am I trying to find out in that last question? What's the point? How many days until, well, yeah, I have no money left over. So I'm trying to figure out X, so that's going to be a question mark. What's Y? What am I aiming to get the hard balance to then? 0, yeah. So the question there is, we're setting Y equal to 0, and then we're going to figure out what X is. So the next thing I'm going to write down is exactly that. I'm going to say, okay, Y is 0, take my negative 2.63 times X plus 50. And we need to just solve this equation and see what happens. What should I do first to solve this equation? I get rid of the 2.63 or the 50? The 50, yeah. We always get the thing furthest away from the variable first. So get rid of that 50. So I'm going to subtract 50 from each side. Take away 50 from this side. That cancels. Take away 50 from this side. 0 minus 50 is minus 50. What should I do next? Yeah, divide by that negative 2.63. Now, sometimes in the homework, when we did this, we could pretty much do it in our head. It was something like 8 divided by 2. No big whoop here. Just whip out your calculator. What is negative 50 divided by negative 2.63? And that's going to be our estimate of the number of weekdays till we have no more balance in our card. Anybody? 19.01, yeah. So I can say about 19 days. That just confirms what our spreadsheet did. So you have multiple tools in your tool belt. You can whip out a spreadsheet to analyze problems like this, which I do as often as I use algebra. I mean, just because I teach math, you think when I have a problem like this at home, I'm going to whip out algebra and solve it. I usually don't. I put it in a spreadsheet most of the time. So a spreadsheet's a great way to solve it too. All right, so I'm going to give you guys a few minutes to finish up writing things down for these questions here or work on your spreadsheet. And then we'll take a look at question number 7 and maybe another question or two in the homework for 3. All right, yep. Let's see. Here. Yeah. Oh, here's a quick way to do it.
Excel.
You already did that. You already did that. Take one. So just look at my spreadsheet and double check my formulas, see if it makes sense to you. Underneath this one.
Oh, didn't copy the formulas. Oh, didn't copy the formulas. Okay.
It didn't copy the formulas. So here are the formulas should be right next to the okay. So here's a trick. In Excel, you just have to answer it. Anytime you end up actively inside Excel, if you try to code somewhere else, it tries to make a note of Excel, which is often a problem. So the thing to be safe is if you're working in Excel and you get out of Excel, it's so we want to enter the formula 9x 175. Anybody else have a question? Yeah, we just want to confirm. Yeah, so it's probably a race of formula, so G2. Yes. Here, yeah, so right? All right. Easy. How's it going? Emily is doing well. All right, so we're going to go over a couple homework problems in just a minute here. I'm going to go over question number 7. Yeah, we're going to take a look at number 7. So if you haven't already logged into Canvas, get into Canvas, head over to the homework for 3.3, and then look up problem number 7. I wanted to do this one together, but if we have time, we'll do another one. I've got some data here from the Bureau of Labor and Statistics about healthcare professionals. Homework 3.3, number 7. So ultimately what we want to do is pretty much based on the top of the table here, we're going to create a linear line. So what they're telling us here is that in 2008, these are the employment numbers. Now think about that for a second. In 2008, do you believe that there were 14,000 healthcare professionals in the U.S.? Or does that number seem a bit small? How many people are in the U.S.? 300 million, yeah. There's way more than that healthcare workers. So there's an important note at the top of the table that says these employment numbers are in thousands. So how much is 1,000,000? A million, yeah. So that's really 14,336,000 people. Okay, and often when you look up data, so they don't have to show huge numbers, they'll have little side notes that say, hey, these numbers are in thousands or these numbers are in millions. So this is homework 3.3, number 7. Okay, so first 2 times I did this problem, I got it wrong because I could not read the fine print. So I'm helping you guys out with that. Here's the next thing. They're also telling us that from 2008 to 2018, they expect there to be a 22.5% increase. Okay. Now, is that 22.5% per year or something else? What's that? Yeah, it's 10 years. Yeah, not per year. So how much change would there be per year then? Percentage-wise. If it's 22.5 over 10 years, what would it be over 1 year on average? Yeah, about 2.25. Yeah, just shift that decimal place over, divide by 10. Okay, so those are some things we're going to need to do. All right, so next thing, come down here. So based on the prediction, what's the prediction? That we're going to have a 22.5% increase based on the starting value. And what is the real starting value? Not 14,000, but 14 what? 14 million. They want us to use those 2 numbers to predict how many healthcare workers there are going to be in 2018. Whip out a calculation, tell me what you get. I ended up with 17,561,600. With that, I'll go over how I got that. So I think it's going to be 22% higher than 14 million. I think it's about 17 million. I'll put that on paper. In 2008, I start. 14 million was 336,000. And then I want to increase by 22.5%. So there's two ways to do this. One way is to take 22.5% times 14 million and then add it back on to 14 million. What's the way I went over to do this yesterday, thinking about 100,000? I'm sorry, 100%. Anybody remember how we did a percent increase with 100%? Yeah, use 122%. Yeah, the two because it's an increase of 22%. That means the 2018 value is going to be 122.5% of what we started with, which means I can just take that 14 million times this as a decimal. So I'm going to on my calculator take 14,336,000 and multiply by 1.225. And that should give me that 17 million number I came up with. It was 561,600. But double check you get the same thing. Doing okay on that now? So there's nothing wrong with doing it the other way, multiplying by 22% and then adding it back on. That's totally cool. But sometimes thinking about it out of 100% can be a benefit. Just an option here. Oops. Let's see. All right, back to the problem. So I think we have an answer to the first part. 17,336,561. There's the number of workers, and they're reminding us the thing I have trouble with fine print sometimes. Those numbers are in thousands. They want us to write that in words. Not a big deal. 2 million. Thousand. All right, on average, how many healthcare workers will be added each year during this period? Let's see. So first, did 17 million get added over the 10-year period from 2008 to 2018, or is that just how many we ended up with in 2018? That's just how many we ended up with, yeah. So there's two ways to answer the next question. For those of you who did just calculate 22.5% of 14,000, that's the increase over 10 years. Otherwise, we have to subtract our 17 million from the 14 million. And then what after that? That gives us a 10-year change. What do we really want here? Right. Yeah, divide by 10 to get the 1-year change. So do some math, see what you think the change per year is on average. I'll do some math and we'll see if we agree. So, spreadsheets. So I want the change in workers per year, which is a rate of change. That's our slope. So if I typed it correctly, I think this is the number. Some commas in there so I can read it. I think it's about 300,000. 14 million to 17 million is 3 million. Divide that by 10. Yeah, 300,000 seems reasonable. So see if you can come up with that same number. So we take the increase in workers, right, which is that 22.5% of what we started with, and then I divide by 10 years, and that should be the 322,000 workers. So about 322,000. And again, that's workers per year. All right. So if you haven't filled that in, feel free to fill that into your homework. 322560. And I think most of the time you can put commas in there, and I do that often to make sure I have the right amount of zeros so I get the right numbers. There's one reason I like my spreadsheet better than my calculator, because the spreadsheet throws commas in there. Some calculators do. Does anybody have a calculator that throws in commas? No. My recollection is on my Android phone, my calculator on that threw commas in for me, which I thought was pretty cool. All right, we're making progress. So the number we just calculated, workers per year, is that a horizontal intercept on a graph, a vertical intercept, or the slope? Yes, the rate of change. That's workers per year is definitely slope. All right, here's the most challenging part. Can you write an equation where W is acting like Y and T is acting like X? So what's our slope and where do we stop? And catch here is T is the number of years after 2008, right? So 2018 would be 10 years later. And so give it a shot, write something down on paper or here. Don't submit yet. Let's talk about whether it's right or not. New page. We're looking for an equation like Y equals mx plus b. M, remember, is our slope. B is our starting point. Instead of Y, we're using a capital W. And instead of X, we're using a T. What's our slope here? What number did we just calculate for slope? It was 322,000. So that was 322, was it 560? 560 times T. And then what's our starting point here? How many workers we started with? Not the 17, that's how many we end up with. The 14 is where we start off with. And it's not 14,000, it's really 14 million. That's going to be the 14,336,000. So I think that's going to be our formula here. So let's read the problem again, make sure that makes sense. We're going back to that problem. Write a linear relationship. Okay, that's the Y equals mx plus b kind of thing. But here they say let W be the number of workers. Does it say number of workers or number of workers in thousands? It just says number of workers, right? So we were right in making it 14 million, not 14, what looked like 14,000. And T is the years after 2008. So how many years later is 2018? 10 years later, right? So if we take 10 times this number, that's going to give us 3 million. If we add that onto 14 million, what are we going to get? 14 million plus 3 million is 17 million, right? Which matches what we calculated. So I think that's the right formula. So on these kinds of problems, you're just going to really slow down, read them carefully, write lots of stuff down. If you think you can do these by just looking at it, doing something on your calculator and typing in the box, I can't. Like I mentioned, not reading the fine print, not writing stuff down. I get this wrong the first couple of times because I was trying to just get it done. All right, we are out of time for fun with math today. If you get stuck on any homework problems for 4 and 3 over the weekend, hit message your instructor and we'll bring them up in class. And we're going to start 3-4 on the next class. If you finish this, feel free to turn it in today. Don't forget there's also that spreadsheet to submit in Canvas. So you got to give me your link or upload your file. That's cool.
Thanks, Fred.